Good evening. Welcome to the Illinois Native Plant Society's Indigenous Plant Symposium for 2021. My name is Bruce Henry. I'm the forest ecologist for the U.S. Fish and Wildlife Service, Midwest region. I'm stationed at Clarence Canyon, Great River, and Middle Mississippi River National Wildlife Refuges. Tonight, I'm going to talk to you about floodplain forest management and restoration within the Middle Mississippi River, specifically on Middle Mississippi River National Wildlife Refuge. I'm going to touch a little bit on this year's plant symposium theme, putting theory into practice with regards to ecosystem restoration and management. The general outline of what we're going to talk about tonight is a background on the Middle Mississippi River, an intro on the refuge focal area, a little bit about the natural community management in the Middle Mississippi River National Wildlife Refuge, and specifically priority resources of concern that the refuge has identified, refuge forest habitat goals and objectives, problems and constraints associated with those goals and objectives in forest management, and an intro to our restoration and management strategies here on the refuge. Last but not least, we're going to speak briefly about partnership restoration activities on the refuge. Takeaways for you as a viewer may include background about the Middle Mississippi River and the corridor, an intro to refuge habitat management and planning, an introduction to the drivers of forest ecology in the Middle Mississippi River and on the refuge, and some common strategies to implement wildlife habitat management in similar forest types. Now, you may ask yourself, what is the Middle Mississippi? The Middle Mississippi River is defined as the 650,000 acre floodplain between the Missouri River and the Ohio River confluences. And on the map to your left of the screen, it's shaded in green. Now, specifically, the Middle Mississippi River National Wildlife Refuge, the focus of the goals and objectives and strategies of tonight's talk, is the 8,000 plus acre National Wildlife Refuge owned and managed by the U.S. Fish and Wildlife Service, depicted in the map here in purple shading. There are 7 divisions: Monroe County, the northernmost, and the southernmost down in Randolph County. Just what is it that makes the Middle Mississippi River corridor so special and ecologically unique? Now, it's the convergence of those 4 major physiographic regions that all meet right there at the Middle Mississippi River. The river in the map to your left is depicted in the teal color from confluence to confluence. Those 4 physiographic regions, starting on the top, is the Prairie Peninsula in blue outline. Coming from the east across the Shawnee National Forest is the interior low plateau in red. To the west is the Ozark Plateau in green outline, and to the south is the Gulf Coastal Plain or Mississippi Alluvial Valley in purple. And those other shadings there, as you see, are bird conservation regions and partners in flight physiographic regions that are all based upon those 4 physiographic regions. And it's that convergence of those 4 physiographic regions and all the species therein in this one little area that makes this a very special and ecologically unique zone. The Middle Mississippi River corridor, a little bit of background. In the 2008 hydrogeomorphic analysis, the Middle Mississippi River is subdivided into 3 distinct ecoregions, sometimes called reaches. The northernmost, Reach 1, is called the American Bottoms ecoregion. 2 refuge divisions are found here. This region is known for its once expansive bottomland prairies and savanna communities, where the bottomland flora met the fire regime of the Grand Prairie. Modern days, it's agriculture and a little bit of floodplain forest. The middle reach, Reach 2, is the Kaskaskia River ecoregion. The remainder of refuge divisions are located in this reach. Historically, this had some of the bottomland prairie, but forest was dominant. Generally, the northernmost point of bald cypress native range is located in this reach. Noteworthy forest tracks here include Oakwood Bottoms, Fountain Bluff, Union County Refuge, and the Cape Bends area. In the southernmost reach, Reach 3, is the Thebes Gap ecoregion, all the way down in between Cape Girardeau and Caro. Located just south of one of the most unique geologic features of the entire Mississippi River, the Thebes Gap ecoregion historically contained a vast complex of bottomland hardwood forests and cypress swamps and bottomland lakes, similar to what we can still enjoy at Horseshoe Lake State Fish and Wildlife Area and Cypress Creek National Wildlife Refuge. The Middle Mississippi National Wildlife Refuge does not have any managed lands within that reach currently. These three maps depict what we call the conservation estate of the Middle Mississippi River corridor. All these polygons denote partners that work together to manage lands and resources in the public trust. The refuge has consulted with all of these neighboring partners to formulate the refuge's habitat management plan. You can see the refuge properties denoted in purple shading. Dark blue shading is Missouri State properties, MDC and DNR. Orange shade is private lands, NRCS easements. Illinois DNR is in light blue, and then Shawnee National Forest owned and managed property is in the sky blue. Modern day land cover within the Middle Mississippi River corridor can be seen in these three maps. In true Midwestern fashion, agriculture dominates. The U.S. Geological Survey flies the entire upper Mississippi River system from Caro northward to St. Paul, collecting valuable land use classifications. These land use classifications that you see here are based on the 2010 flight. This year, they are planning to release the next set of updated land use maps. We're all looking forward to it. While on the land use topic, we'll discover the land use change in the Middle Mississippi in the last 200 years. Based on the General Land Office surveys, Yin et al. In 1995 published a study depicting that 53% decrease in the forest cover in the Middle Mississippi River corridor. These land cover changes in the Middle Mississippi are primarily a resultant of conversion of forest to agriculture, made possible by a world-class levee system. Compared to all other reaches in the upper Mississippi River system, historically, the Middle Mississippi had the highest percentage of forest land cover, as these pie graphs show. Middle Mississippi is highlighted in the bottom. Of the three reaches in the Middle Mississippi, Reach 3, the Thebes Gap reach, retains the highest percentage of historical forest cover. Based on these General Land Office surveys data in the 1890s Mississippi River Commission surveys, the survey analysis shows the breakdown of forest communities historically in the Middle Mississippi River. Note the dominance of bottomland hardwood in the Thebes Gap ecoregion, and the absence of floodplain forest and riverfront forest in that region as well. Bottomland prairie dominated the American bottoms, and the forest communities in the upper two reaches were primarily floodplain forest and riverfront forest. Now to speak a little bit more specifically about the National Wildlife Refuge. Every national wildlife refuge has a purpose mandated through legislative authority. And the Middle Mississippi River National Wildlife Refuge is part of the National Wildlife Refuge System. The mission can be read here. Specific mission statement from this refuge states to restore, manage, and protect the ecological communities of the Middle Mississippi River Valley and its watershed while providing environmental education and wildlife-dependent recreation. Now to speak about the purposes mandated through legislative authority. In all of this word mess, I have highlighted in green some aspects of this refuge's purpose I feel may be relevant to this audience. Note, an inviolate sanctuary for any other management purpose for migratory birds. Next, the conservation, maintenance, and management of wildlife resources thereof and its habitat thereon. And third, the protection of natural resources, the conservation of endangered species or threatened species, including fulfill various migratory bird treaties, and finally, the conservation, management, and restoration of the fish, wildlife, and plant resources in their habitats. Long story short, the refuge is mandated by law to uphold these purposes. And these purposes are outlined by a strategic habitat conservation feedback loop that outlines our path from theory through planning, management practice, and back through time to the planning stage. Now bear with me here. To link the symposium theme of putting theory into practice, work through the theoretical cloud and planning process, like the Habitat Management Plan, or HMP there, circled in red, the process of step-down plans, and into the Habitat Management Actions phase, aka the practice, and back in time, back through time, into the theory cloud, from theory to practice. Now through 2020 and early 2021, Refuge staff have drafted a habitat management plan for the Middle Mississippi River National Wildlife Refuge. This HMP is a step-down plan that lays out the vision of management actions in a 15-year life cycle. It steps down the goals and objectives from the larger overarching plan and evaluates additional resources such as the latest and peer-reviewed wildlife and habitat research, as well as these 4 publications on your screen. To the left, the Middle Mississippi River HGM, a 2008 Heitmeyer. The Lower Mississippi River Joint Venture Forest Resource Working Group plan from 2007. And third, the Upper Mississippi River Systemic Forest Stewardship Plan from 2012. And last but not least, the latest 2018 Forest Avian Stewardship Plan, since the U.S. Fish and Wildlife Service loves to manage refuges for birds. Now, all the recommendations and guidance through these documents and our step-down plans have been used by the planning team to formulate this habitat management plan and the forest goals and objectives we will outline tonight. The first tenet of a refuge habitat management plan is the identification of priority resources of concern, all of which must be measurable so management progress can be determined. Here at Middle Mississippi River, the refuge planning team chose floodplain forest as the first priority resource of concern. It is the dominant natural community on that refuge and whose measurable attributes can be ascertained to evaluate habitat conditions for other priority resources of concern. I will elaborate on specific forest objectives in a minute, but indigenous plant richness is a major aim of our strategies, for it is the foundation of the refuge's food web. Note some of the indigenous plants you see here on our left and commonly found in our floodplain forests, like Carex frankii, the smilax, one of the sneeze weeds, Yerba de Tahoe, and our important floodplain species, the northern pecan. Refuge forests can be divided into two broad groups, seen in the table here on the left column, upland and bottomland. Upland forest is only a minor component of the refuge lands, with only about 7 acres located near their headquarters in Randolph County. The remainder of the refuge's 8,000 acres is in a mosaic of these floodplain forest community types, starting from the highest terraces containing oak pecan types, sugarberry types, and through early successional forest communities, including populous communities and salix-dominated communities, down a little lower into maple, ash, elm forest types, and then the lowest elevation woody communities, including shrub swamp and wooded swamp communities. This table also shows a handy crosswalk between the different categorizations of natural communities. One's used in our overarching CCC plan, the Heitmeyer HGM, NV National Vegetation Classification Standard, which is used by the National Wildlife Refuge System, Nelson communities from our neighbors over in Missouri, and the Upper Mississippi River System specific communities. Based on preliminary forest inventory and observations seen here in the table, 92% of refuge forests are dominated by 3 species: black willow, cottonwood, and silver maple. They are abbreviated using USDA plant codes on the left column. These forest species and size demographics drive forest management objectives and strategies. That 1.5% of forests with pecan present is vitally important to refuge forest, for it is the only place where hard mass seed source is present and a high enough elevation for pecan and potentially oak species to grow. These elevations also show the highest herbaceous species richness and have a great potential for restoration and improvement on species richness targets. Shrub swamp communities also include buttonbush, swamp privet, primarily some swamp dogwood, standing black willow, and green ash. Some of these communities may be apt to restore to cypress swamp communities with additional planting. Currently, none contain cypress. Shrub swamp communities are roughly about 8% of the refuge. The next priority resource concern is transient neotropical migrant passerines. This four warbler subset of management, this 4 warbler subset of migrant passerines, many of which nest on the refuge. Some, like the Canada warbler, only pass through, using the treetop Lepidoptera along the Mississippi to refuel their migration to the boreal. Each of these species has a specific ideal habitat requirement considered within forest objectives and strategies on the refuge. Tree roosting bats is our third priority resource concern, such as the Indiana bat, northern long-eared bat, big brown, hoary, evening, and little brown bats all have been detected on refuge in recent years, using refuge forest and adjacent forest to roost and forage. Like birds, the refuge forest management objectives and strategies consider their life history needs a high priority, such as large snag trees with exfoliating bark, trees with cavities, and tree species with shaggy bark, such as the silver maple pictured there in the middle of the screen, or maybe shellbark hickory on our higher elevations. Essential forest demographic data is used to determine where to actively manage our forest on the refuge. This is collected using forest inventory protocols following the U.S. Forest Service's FIA and the United States Army Corps of Engineers Phase II Protocol. This is a mixture of fixed plot and variable radius plots where we can gain forest demographic data such as diameter distribution and species distribution on both the division management unit and refuge wide scale. A preliminary inventory of the Wilkinson Island Division was completed in 2007. Additional surveys are planned this summer for Rockwood Island and Meisner Island Division. Now to the refuge forest management objectives. Our plan is to manage floodplain forests to meet primary forest variables intended to provide suitable habitat for priority resources of concern. Things include our tree species richness, tree diameter size class distribution, tree age class distribution, forest structural dynamics, like this varied strata canopy in the picture to the right, shrub richness and density, and a myriad of wildlife habitat factors based on our priority resources of concern life histories, like bat roost trees, diverse ground flora to provide myriad forage resources for birds and bats, like the dagger moth caterpillars on Persicaria there on the right, as well as canopy structure, preferred by certain priority birds of concern. This table depicts the landscape scale forest objectives on the refuge. This is the basis for all refuge forest management objectives. As you can see, maintaining a contiguous block of large forest acres is desired. Secondarily, a good distribution of size and age classes is a landscape scale objective, including mature forest, pole forest, which is a 6 to 12 inch range, DBH, and regenerating forest of smaller than 6 inches diameter. Currently, over 90% of the forest is in the mature forest stage. This is adopted from the 2012 Systemic Forest Stewardship Plan. This next table, also adopted from the Systemic Forest Stewardship Plan, roughs out the stand level objectives for refuge forests. We use these in conjunction with our management unit boundaries as management unit scale objectives. Considering priority resource of concern habitat management, the refuge forest objectives have set higher targets for overstory species richness and established new criteria for mid-story species richness. Other priority resource of concern related factors modified by the refuge include a higher threshold for snags and cavities per acre to better accommodate tree roosting bats. The second column identifies trigger points that indicate the forest stand or management unit may warrant active management. For example, if we don't have enough snags per acre, we could girdle and create some snags. Or if our canopy cover is greater than 80%, we could break that canopy up with some active management. Species richness objectives included in the habitat management plan call for at least 3 codominant native tree species in the stand level. The refuge uses the Van Apeldoorn flood inundation model from the USGS to model the mean growing season flood days, or on average, how many days during the growing season certain areas of the refuge are flooded. Since certain species are more flood tolerant or flood sensitive than others, it gives us spatial targets for where to focus our management strategies, which will be discussed soon. The higher elevation zone in green in the map below, 0 to 30 days inundated during the growing season, is capable of higher plant species richness and will be a priority target for active management. The lower elevation zones, like yellow in the map there, 30 to 80 days inundated, are acres that may see more flood-induced mortality and have certain strategies or target species unique to that zone. Along with overstory species richness objectives, we have shrub and small tree objectives as well, also based on these different flood tolerance regimes. We've got a minimum of 5 species per management unit. That's across the entire unit or stand. And they're broken up in these 2 tolerance categories. These are based on a 1975 Molenbrock study of the lower Mississippi or the middle Mississippi River Valley. A little bit more about that Van Apeldoorn model. Flood and elevation models produced by the USGS. Picture or maps of our Beaver Island division in Randolph County depict how LIDAR digital elevation models on the right are utilized to formulate these inundation models. You can see how the lowest elevation LIDAR, the white in the middle of the unit, is depicted as the most flooded zone within that unit. We use modeling data like this to spatially plan where we do our plantings or management actions. Look at the colorful 2-part graph on the left. Top is pre-channel training, pre-lock and dam, and pre-flood control reservoirs in the upper Missouri River. It depicts the flood stages on an annual or on a monthly basis over a time period from 1878 to 1899. Note the period of springtime flood pulse and then a regular annual low stage. Conversely, the bottom graph is the modern, I will say pre-1996, post-channel training, post-1950s flood reservoir construction gauges that reflect more of a unimodal distribution with almost no regular annual drawdown period. Now, it's that regular annual drawdown period that allows the terrestrial communities along the river to reset, tree regeneration to germinate and establish and recruit into the overstory, and wildlife species to live out their life histories without the threat of flooding. Note the graph on the right. It shows just how much more water is pushed down the river post 1993, depicted in the orange line. The blue and red lines are the historic, and the orange line depicts a much stronger, more flashy river from 1993 to 2019. I'll add the 3 most intense floods on record are from 1993 to 2019. This results in increased tree mortality, the loss of species richness throughout the system. It filters to only hydro-extremophiles, or species that can only take and handle the most extreme flooding events. It results in an increase in coarse textured soils like sand and a further loss of species richness. And the highest elevations are very important for species richness. To dovetail into natural regeneration in the forest, the pictures show a depiction of the typical progression of tree regeneration in the Mississippi River system. The modern flood-related stresses to the system have a severe impact upon forest succession, particularly forest regen. When seedlings do germinate, the picture on the left, the mature, often maple-dominated forest stands don't provide enough light for the recruitment into the midstory, leaving them vulnerable to the inevitable killing flood the following spring, summer, and fall. Other challenges, we've talked about near annual flooding during the growing season, the minimal light, a select species that are that flood tolerant and shade tolerant, land use history, and of course, pressure from exotic invasive species. The strategies to recruit the next cohort of seedlings into the canopy include regular forest inventory and regeneration monitoring, and applying canopy disrupting regeneration focused active management to provide enough sunlight to the seedlings for recruitment. This is the main strategy we intend to employ at the Refuge to meet our landscape level forest management objectives. It includes regular surveys for regeneration, especially during low flow periods and potential periods of irregular drought when we may have a flood-free period to complete those management actions and get those seedlings into the next size class so they're not killed by that next flood. Another modern flood-related stressor that impacts the drivers of forest succession can be seen when exploring the gap dynamics in the refuge forests. Typically, when a forest gap occurs due to the windfall event or a tree mortality event, forest succession goes through irregular paces of herbaceous to seedling to sapling, some less herbaceous species, more trees, bigger trees, stem exclusion stage, etc., until the new forest is established. But in the modern Mississippi River floodplain, the lowest elevation forests are subjected to long duration flooding for beyond their physiological limitations, so they die. An herbaceous community responds well, which is nice until the Japanese hops gets established. Without chemical intervention and increased shade, the hops will persist and prevent any recruitment and native species from establishing. I refer to this as an arrested succession, with hops and flooding teaming up to prevent gap closure. This phenomena also occurs with reed canary grass, sometimes in the middle Mississippi, but typically in pools further north. You can see the photo here. I've got a circle around the small canopy gap that I've got a photo of there on the right, showing what that looks like on the ground. It's, as you can see from the growing season flood day model on the bottom left corner, that canopy gap corresponds with the lowest elevation on that island division at Beaver Island Division, Randolph County. And that flood has killed the overstory over a period of years and left a very happy hops community. As you can see on the right, it's even starting to act a little bit like kudzu, coating everything and climbing up some snags. Another photo here of a Japanese hops waiting in the wings in a stressed populous community on a different island division. This is just hops waiting for more light. Hopefully this stress canopy recovers if we get a couple of dry years. This photo was taken mid-2020 after a particularly rough couple years of flooding. So these trees may recover. They may succumb to the flooding, and the hops will dominate just like in those previous photos. Now, we do have a set of strategies set to combat this arrested succession in these canopy gaps. We use, including identifying priority canopy gaps, including gaps large enough to impact edge dynamics, gaps with hops present, gaps in priority management units, and canopy gaps accessible to crews. Controlling hops with foliar herbicide to, one, release natural regeneration, which is pretty rare in modern days, or more likely a follow-up with the planting of tree saplings or tree seedlings. Following that, a 2 times annual follow-up treatment using foliar herbicides or mechanical treatments, if possible, for up to 3 years. So essentially treat the hops and underplant appropriate flood-tolerant species in that canopy gap. Now, we also have challenges to tree planting, one of our major strategies to overcome our lack of regeneration. Since our problems with regeneration are established, we use two types of tree plantings: traditional open canopy planting, typical of old field afforestations, and underplantings. For both types, we use root production method trees, or RPM, trademark, which is a type of containerized tree stock that are tall, typically over 2 feet tall, and generally about the diameter of your pinky when you buy them. And we use those because they have that elevated height to better withstand the annual flooding pressure that a bare root seedling wouldn't typically succumb to. Traditional planting is used in the Middle Mississippi River National Wildlife Refuge to establish forests and abandoned agricultural fields, such as at Cranes Island Division and Horse Island Division, where more planting is also required. Also in gaps, canopy gaps, like the situation I presented earlier. Underplantings are planned for higher elevation zones where, like that green 0 to 30 day zone, where additional species are needed to meet our species richness objectives, either for the future overstory as a supplementary or to meet the shrub richness goals. And last but not least, our partner restoration efforts. The Refuge partners with the Army Corps of Engineers on HREP projects, or Habitat Rehabilitation and Enhancement projects. The Corps administers this restoration program as mandated by Congress. This is a multi-million-dollar, the Cranes Island is a multi-million-dollar project underway that includes side channel restoration and tree plantings in old fields, as well as a forest-related fine textured soil building strategy called a sediment deflection berm, seen in the map to your left as the green line. This raised earthen berm is intended to deflect heavy current and associated coarse sediment toward the main channel, leaving behind it an annual accumulation of fine, silty sediment that will hopefully build the building blocks of the soil types that hard mash species like oak and pecan prefer. Also included are some wetland features and an excavated side channel. Pictures from later in 2020 of active construction, digging of the side channel and some construction of that beginnings of the sediment deflection berm there on the left. There's also a Harlow Island Division HREP project in the wings. It's currently past the feasibility stage and has not started construction, but this project seeks to restore side channel habitat and improve quality of existing side channels. It also has a sediment deflection berm, just like Cranes Island, depicted in the map in that kind of tan colored line. Also in the green are some elevated berms that are intended to raise the floodplain elevation to that 0 to 30 stage to allow for higher species richness and hard mass establishment. I'll leave you guys with an Aldo Leopold quote and take any questions that you have.